Okay, so this is the second lesson for section 6.4, the quadratic formula. In the first lesson, we discovered this quadratic formula right here. X equals negative e plus or minus the square root of b squared minus 4ac all over 2a. I showed you the proof of that, and then we learned how to use that to find the x-intercepts of a parabola if it's in standard form. Now let's just quickly remember what standard form is. It's y equals ax squared plus bx plus c. Okay? So we know how to use this quadratic formula to find the x-intercepts if the parabola is in this form. This section, what we're now going to do is use those solutions to help us graph the parabola. If you remember, having the x-intercepts isn't enough to be able to graph the parabola. We also need the vertex. Okay? So how do we find the vertex? We need the x-coordinate and the y-coordinate of the vertex. If we remember, okay, from previously in the year, the x-coordinate of the vertex is the axis of symmetry. Okay? Because, let's make a quick diagram here for our reference. Not in highlighter. We'll do it in a nice red. Okay? If here's my parabola here. Okay? I know that the vertex is right in the middle of the parabola because parabolas are symmetrical. Okay? I also know by definition the axis of symmetry is a vertical line that goes through the middle of the parabola. So it goes through the vertex. That's why the x-coordinate of the vertex is the axis of symmetry, because the axis of symmetry goes through that vertex. Okay? So, previously what we've done to find the x-coordinate of the vertex, or the axis of symmetry, is add the x-intercepts and divide by 2. Okay? So if you've already solved for your x-intercepts, you can still do this. You can add your x-intercepts and divide by 2. Or you can use this generalized rule that will work for all parabolas in standard form. To find the x-coordinate of the vertex, you can use negative b over 2a. So negative b over 2 of whatever a is. Okay? I'll show you why we can do that. Okay? So remembering that the axis of symmetry is in the middle of the parabola, so normally we find just by adding x-intercepts and dividing by 2, finding the midpoint of those x-intercepts. That'll find us the middle of the parabola, which the axis of symmetry will go through. And we know the axis of symmetry is the x-coordinate of the vertex. Okay? So hopefully we followed that train of thought there. So the quadratic formula tells us that our two solutions, our two x-intercepts of a parabola are negative b plus the square root of b squared minus 4ac all over 2a. And the other one is negative b minus the square root of b squared minus 4ac all over 2a. Okay? So keep in mind what we've known before. To find the axis of symmetry, all we have to do is add our x-intercepts. So these are the two general x-intercepts of any parabola in standard form. So let's just add them and divide by 2 to find the midpoint, which is the axis of symmetry. So I'm just going to add these two, and they have a common denominator, so that's going to be nice and easy to do. So I'm going to add the negative b minus square root b squared minus 4ac. This is all over 2a. 2a was the common denominator. And then I have to divide by everything by 2 to find the midpoint. Okay? Now, let's look what happens. I have a positive b squared minus 4ac and negative b squared minus 4ac. I love it when that happens, when something so big is going to cancel out. We have a positive b squared minus 4ac minus a b squared minus 4ac, square root of b squared minus 4ac, I should say. Okay? So those cancel. I have one that's positive, one that's negative, they cancel. Just like if I had a positive one and a negative one, they'd cancel. Okay? What I also have, I have a negative b plus another negative b. So negative b minus b, that just gives us negative 2b. So that's all I'm left with in the numerator, negative 2b. Okay? So I was able to do that because negative b and negative b are like terms. Okay? And I have it all over 2a. Okay, negative 2b over 2a. And this should, and then this should all be all over 2. Okay, so I have to divide this by 2. Dividing by 2 is the same as multiplying by the inverse, multiplying by 1 over 2. Okay, so that would give me negative 2b all over 4a. I can simplify that. Negative 2 divided by 4. I can simplify to negative 1 over 2. I still have my b and a there. I don't need to have that negative 1 there. I can just leave that 1 as invisible and have this negative b over 2a. And you can see the general axis of symmetry, or x-coordinate of the vertex, those two things are the same. The general formula for that is just negative b over 2a. Okay, so we can use that anytime we want. Okay, now that we've gone through the solution of that, let's practice graphing quadratics that are in standard form. So I'm going to do one example for the 3 possibilities. If we remember from last time, a quadratic can have 2 roots, 1 root, or no roots. So let's do one where the quadratic has 2 roots. For example, this one here. So I have, for the quadratic y equals negative 5x squared plus 8x minus 3. It's asking us to find the x-intercepts. So to find the x-intercepts, I could solve it by factoring, or I could solve it using the quadratic formula. I want us to practice using the quadratic formula, so I'll go ahead and do that. X equals negative b, so negative 8 plus or minus the square root of b squared, so 64, minus 4 times a times c. A, c. Okay? All over 2a. A is negative 5. Maybe before I did this, I should have made a list on the side here. Okay, if this is in standard form, my a is negative 5, my b is 8, and my c is negative 3. And then I just plugged all of those into the quadratic formula, and this is what I got. If I go ahead and simplify this, okay, if I go ahead and simplify everything I have there, put all of that in on my calculator, you can do it in stages. If it wanted the exact roots, you would first simplify it just what's under the radical. And you would find out that 64 minus 4 times negative 5 times negative 3, okay, that all goes to 4. Make sure you do the multiplications first and then subtract that product from 64. Okay, make sure you follow the BEDMAS rules. And this will be all over negative 10. Now we have to consider the positive and the negative square root. So x could be equal to negative 8 plus 2 over negative 10. And our other solution is negative 8 minus 2 over negative 10. Okay, square root of 4 can be positive 2 or negative 2, because positive 2 squared is 4, and negative 2 squared is also 4. We go ahead and solve this. Negative 8 plus 2 is negative 6. Negative 6 divided by negative 10 is 0.6. Negative 8 minus 2 is negative 10. Divided by itself is just 1. So those are our 2 solutions, 0.6 and 1. To find the axis of symmetry, I can add those x-intercepts and divide by 2. That will give me the same answer as if I just do negative b over 2a. That's the general formula. Okay, so I'll do that. Negative b, so negative 8, all over 2a. 2 times negative 5 is negative 10. This will equal 0.8. Okay, to find the vertex, the x-coordinate of my vertex is my axis of symmetry. Okay, so it's 0.8. My y-vertex, I just plug in that 0.8 for x into my formula here. So I'll have negative 5 times 0.8 squared plus 8 times 0.8 minus 3. Punch that all into my calculator there, and I should get 0.2. Okay, so my vertex is an xy coordinate, so it is 0.8, 0.2. Okay, so x-intercepts are 0.6, 0.1. Vertex in the middle of those x-coordinates is 0.8, 0.2. So let's go ahead and graph all that. Okay, so I know my vertex is at 0.8. I'm going to make my scale go by 0.2 to make it all fit on here nicely, so it'll be spaced out. Okay, so choose your scale appropriately. I'm going to make my scale go by 0.2 vertically and horizontally. So if my vertex is at 0.8, 0.2, I'm going to go 0.2, 0.4, 0.6, 0.8, and then up 0.2. There's my vertex. at 0.8, 0.2. Make sure you label it, even though that label doesn't work very well. It's not very clear, but you know what it is. Okay. My x-intercepts are at 0.6, 2, 4, 6. So it's at 0.6. And also at 1. Okay. At 1. And my parabola looks something like this. And that is a very nice looking parabola. Okay? So, let's go on to the next example. Graph a quadratic that's a standard form if it has one root. Okay? We remember from last time, if it has one root, our discriminant will equal 0. Our b squared minus 4ac will equal 0, which eliminates the possibility of there being a positive and a negative. Positive 0 is the same as negative 0, so that doesn't give us two solutions. We'll only get one. Okay? So to find the x-intercepts, let's just verify that. Okay? X equals, first I'll label my a, b, and c. My a is 1, because I don't see a number in front of the x. I know there's a 1 there. My b is negative 10. And my c is 25. That looks like a 70, doesn't it? That negative 10. Let's redo that, and let's redo that equal sign. A equals 1, B equals negative 10. All right, so x equals negative b. Negative 10 is just 10, plus or minus the square root of negative 10 squared, that's 100, minus 4 times 1 times 25, all over 2a. 2 times 1 is 2. Okay, so x equals 10 plus or minus. Okay, we always simplify under the radical next. 100 minus 4 times 1 times 25. 4 times 25 is 100. Okay, so 100 minus 100 is 0. Square root of 0 is just 0. So the only root I have is x equals 10 over 2. X equals 5. Is my only solution. So what that looks like, if I remember, if I only have one x-intercept, that means my parabola is going to touch the x-axis at 5. Okay, it's going to touch the x-axis at 5, and that's the vertex, okay, at the x-axis. It doesn't go through there, it just touches it there. That's why there's only one solution. So it's going to look something like this. But to graph it exactly, we're going to have to do some more work. But first off, so to find the vertex, there's no work I have to do for that, okay? I know the vertex is the x-intercept, okay? It is where it touches the x-axis, so it's at 5, 0. And the axis of symmetry is always the x-coordinate of the vertex, so it's just x equals 5. If I had gone through and calculated it, I would have got these answers, okay? If I had used x equals negative b over 2a, okay? Negative b, so negative 10 is 10 over 2a over 2. I get 10 over 2, which is 5. And if I plug 5 into this equation, I get 25 minus 10 times 5, which is 50. So 25 minus 50 is negative 25. Plus 25 is 0. There's the y-coordinate. Okay, so this is a shortcut. If you only have one solution, you know the parabola is just going to touch the x-axis there, and that is the vertex. So the x-intercept of 5, 0 is the vertex. Axis of symmetry is the x-coordinate of the vertex. Okay, so it's all coming together at this point of the year right now. If you're able to sketch the graph, we know our vertex is at 5, 0. We need to figure out some points to the left and right. 1, 2, 3, 4, 5. So here's our vertex. If I can figure out the y values of points to the left and right, I can make a nice sketch of this graph. Okay. If I plug 4 into my equation here, in for x, I would get a y value of 1. Okay. 16 minus 40, okay, negative 24, plus 25 is 1. And I know parabolas are symmetrical, so if I go on to the right, it'll also be at 1. So here's my parabola that looks something like this. Make sure I label my vertex. And there we have it. There's the parabola. Just another note here. I've already said it a few times, but we only know the vertex which is also the x-intercept for a quadratic with one root. Okay, so therefore, in order to graph, we have to find a point to the left and right of the vertex. So if the vertex is at 5 on the x-axis, I then have to find points to the left and right. So at 4 on the x-axis and at 5 on the x-axis, I found those y-coordinates by plugging in 4 and 6 in for x into my formula there. Okay? Okay, graphing with 0 roots. We know a problem will have 0 roots if the discriminant, if the b squared minus 4ac, if that equals a if that equals a negative number. Okay, because we can't take the square root of a negative number. All right, so graph y equals x squared minus 6x plus 11. Let's just go ahead and verify that this has no roots. So my a value is 1, my b value is negative 6, and my c value is 11. Okay, so x equals negative 6, which is just 6. Plus or minus b squared, negative 6 squared is 36, minus 4 times a times c, all over to a, simplify under the radical, plus or minus 36 minus 4 times 11 is 44, 36 minus 44 is negative 8. So as soon as you see this negative term under the square root sign there, you know there are no solutions, okay? Because you can't take the square root of a negative number. There's no way of squaring a number and getting a negative result. No way, okay? That's why you can't do that. So I won't even write x equals. X doesn't equal anything. We can't. There are no solutions to that. So I'm going to write no roots, no solutions, no x-intercepts. Okay, no roots. So how do I graph this if it has no roots? Well, I'm going to have to find the vertex. So to find the vertex, I have to first find the x-coordinate, which is the axis of symmetry. And I know my formula for that is negative b over 2a. Okay, so negative 6, which is just 6, over 2 times 1, a is 1, so 6 over 2, which is 3. So to find the vertex, I know my x-coordinate of the vertex is the axis of symmetry, which is 3. So my y-vertex, I just have to plug in 3 for x. And that'll tell me the y-coordinate of the vertex. Okay? So 3 squared minus 6 times 3 plus 11, 9 minus 18. Negative 9 plus 11 is 2. So my vertex is 3, 2. X-coordinate is 3, y-coordinate is 2. There's my vertex right there. I'll just highlight that so we can see it. There's my vertex. Okay. Note, we could have also found this vertex by completing the square if we wanted to. I find it a lot less work just to use this to find the x-coordinate, the axis of symmetry, plug that in, find the y-coordinate. But you could complete the square as well and find your vertex. Okay? So once we've found our vertex, this is all we know about our parabola so far. 1, 2, 3, 1, 2. Our vertex is right here. That's all we know. Okay? Well, we also know it opens up because our a value is 1. So it looks something like this. But to find out exactly what it looks like, find points to the left and to the right of 3. Okay? So to find points to the left and right, so I'll calculate the point to the left. So if I put in 2 for x, it'll tell me the y-coordinate. Okay, so if I put in 2 for x there, I will get a y-coordinate of 3. 2 squared is 4, minus 6 times 2. So 4 minus 12 is negative 8, plus 11 is 3. So at 2 on the x-axis, my y value is 3. There's a point. I know parabolas are symmetrical. So to the right one, it must also be at 3. So my parabola looks like this. I will label my vertex. Oops, 3, 2. And there we go. There's that parabola. We only knew the vertex. That's why, in order to graph, we had to find points to the left and right. Okay. And that's it for the lesson. If you have any questions about how to graph a parabola, just let me know.